Welcome to Talk Plus Water, a podcast that takes a deep dive into the world of water with those making waves. My name is Todd Butler, and I'm your host for Talk Plus Water. I'm also the editor-in-chief of Texas Plus Water and the Texas Water Journal. You can sign up for Texas Plus Water by visiting texaspluswater.org, and you can sign up for the Texas Water Journal at texaswaterjournal.org. Both publications are free. My very special guest today is Dr. Ralph Wurbs, who is a professor in the Zachary Department of Civil Engineering at Texas A&M University. Ralph worked in the Water Development Program of the U.S. Army Corps of Engineers for 9 years prior to joining the Texas A&M faculty in 1980. He has a Bachelor of Science from Texas A&M and a Master's of Science from the University of Texas at Arlington and a PhD from Colorado State. He's a fellow of the American Society of Civil Engineers and a founding and honorary diplomat of the American Academy of Water Resources Engineers. Ralph taught many courses at Texas A&M, professional development courses in Texas and abroad, and a graduate water management course several times as a visiting professor at Catholic University in Belgium. His responsibilities at Texas A&M have included serving as head of the department's Environmental and Water Resources Engineering Division, associate director of the Texas Water Resources Institute, and a member of the executive committee of the Interdepartmental Graduate Program in Water Management and Hydrologic Science. His research and consulting have been sponsored by various federal, state, and international agencies. He's worked closely with the water management community in Texas for many years, most notably under the auspices of the Texas Commission on Environmental Quality. Ralph's publications include 3 books from Prentice Hall: Water Management Models, Modeling and Analysis of Reservoir System Operations, and the textbook Water Resources Engineering that's been used by thousands of students in courses at Texas A&M and other universities. His new book, Managing Water in River and Reservoir Systems, Water Resources, International Practices, and Constructed Infrastructure in Texas, is being released by the American Society of Civil Engineers Press this spring. Ralph has also authored chapters in many other books and numerous journal and conference papers and technical reports. His work has been recognized by an endowed professorship, several teaching awards, and various other awards, including the Outstanding Research and Innovation Award of the American Academy for Water Resources Engineers. Ralph was one of the original editorial board members of the Texas Water Journal. In February, Ralph became the inaugural recipient of the Texas Water Journal's Texas Water Lifetime Achievement Award for his work developing the Water Rights Analysis Package, or WRAP, modeling system, which he did with graduate students under the sponsorship of the Texas Water Resources Institute, the Texas Commission on Environmental Quality, the Texas Water Development Board, and the Fort Worth District of the U.S. Army Corps of Engineers. Ralph, welcome, and thank you for being part of Talk Plus Water.
Well, thank you, Todd. I'm glad to be participating here today.
Well, I've just read your bio, and so our readers have some of your background in water, but I'd like to hear how you first decided that your career was going to be focused on water.
Well, as you just mentioned, I graduated in May 1971 from Texas A&M University and with a BS in Civil Engineering. And Water Resources Engineering is one of several specialty areas within civil engineering. Now, back when I was a student, we were general civil engineers, though more recently people can specialize a bit more at the undergraduate as well as the graduate level. But I did become interested in water back then. And then I graduated on a Saturday from A&M and reported to work on a Monday morning in the water development program of the Fort Worth District of the U.S. Army Corps of Engineers. So that's when I really got into water. And what has happened nationwide in this country. We think about from the 1940s through the 1980s as being the construction era, nationwide major water projects. And so in my early career, I sort of caught the latter part of that construction era with the Fort Worth district. And then, of course, water evolves year by year and decade by decade into different emphasis. And it was 1980 when I moved to the faculty of the Texas A&M University Civil Environmental Engineering Department, and my focus since then has been totally on water.
Well, let me ask you a little bit about your transition from graduation to the Corps. First of all, boy, you took 2 days off. That was and then you started. That's impressive.
I needed to be on the payroll.
Yeah. But I imagine I was thinking about what you were saying, and as soon as you said 71, I thought, so when you took that job, you just gone through your education, and you had started the Corps. I mean, I imagine you thought, hey, I'm going to be involved with building a lot of reservoirs around the state of Texas. And, that was, like you say, that was when the end of the reservoir construction boom was happening. And I'm just curious, did you think, okay, what am I going to do? Is this, I've kind of trained for this one thing. How is my career going to unfold now that the whole kind of, framework of what's going on with Texas water is changing?
Oh, I think we all evolve as the world around us, our working environment, our personal environment changes. And in the beginning, I couldn't forecast what was happening over the decades ahead. I've enjoyed very much a career in water. It began more engineering, design, construction, and that was a great experience. It's evolved, like the entire community in which we live, in the water community, into more management, water allocation, management of existing systems, a massive infrastructure that's now in place, and environmental protection and so forth. So I've sort of changed as the water community changes, and I think that's sort of what we all do.
Well, some people evolve better than others, and I think you evolved much better than a lot of other folks, for sure, in the water community. And I'm curious. So were you really thinking about and modeling a whole lot when you first began, or did that become something that you had to kind of go back and relearn that, or how'd that work out?
Well, I've been around long enough to sort of live through the whole concept of the computers becoming a major part of our lives. I can remember the beginnings of a lot of changes being motivated by computers. And I would say probably computer modeling has been a major aspect of the evolution of water management for several decades now. And I've always been interested in various aspects of water planning, management, non-modeling aspects, as well as computer modeling. But I've found that an interest in computer modeling is given me an opportunity to participate from an academic perspective in this whole endeavor of managing water resources. And so I guess my thoughts have sort of evolved not only with the water management community, but the whole concept of computer modeling, computer technology, sort of that more broader world in which we all live too.
Right. Now, I got to know you through the Texas Water Journal. And so just kind of thinking back to that, probably around, I think, maybe 2007 7 or 8, sometime around then, when Kathy Alexander and Robert Mason and I were trying to figure out, hey, how are we going to start this water journal? You were the person who reached out to us from, I think, the Texas Water Resources Institute at that time about partnering with the Water Resources Institute to publish the journal.
Well, the way I remember that, Kathy Alexander mentioned to me that you and she and Robert Mace and maybe others were thinking about creating a Texas Water Journal, and she was wondering if maybe I might be interested in maybe becoming part of the editorial board and participating in different. And I thought it was a fantastic idea. The whole concept of a journal looking at interdisciplinary, practical issues and applications and aspects of water management in Texas, which is a unique water state. And so I was excited to join with you guys. But at that time, I was a civil engineering professor back in my department, but I also had an office, and I was serving as associate director of the Texas Water Resources Institute and working closely with that group, which included an editorial staff, a communications manager, an actual staff that had the experience and the capabilities to publish technical reports and other publication. So it seemed to me a perfect fit for the Texas Water Journal effort to join with the Texas Water Resources capabilities. And as I recall, you and Kathy, everybody was pretty much on board with that. And we pretty much wasn't a lot of discussion. We said, let's do it. Let's go on. And that's part of my memory of that.
Oh, absolutely. Because we didn't really know how to do it. We were trying to think, so how do we start this thing? What are we going to do? Are we just going to kind of like write it out on, longhand and make copies at the, local copy place and mail it to our friends, or what are we going to do? And so, of course, you brought in the staff at TWRI, Kathy Wyeth and Leslie Lee, who were, the original folks who were, working with us to get it off the ground. And boy, it just turned out so well, and I think so much better than it would have if Kathy Alexander and Robert Mason and I tried to produce this in our garage or something. And so I thank you for that. You made my life probably a lot simpler or easier than I realized.
Oh, you're welcome. I appreciate the opportunity to be part of those early days creation of the Texas Water Journal. And
you've also been a contributor in terms of being an author. Not only did you serve on the editorial board, but we published, I think, 3 of your articles. And so that kind of brings me to one of the main reasons why we're talking today is that you are the inaugural recipient of the Texas Water Journal's Texas Water Lifetime Achievement Award. And, the board members of the Texas Water Journal 501c3 voted you in as the recipient in February. And so I thought about, how do I have some, style with this thing? I mean, maybe what I do is I'll call you at 3 a.m. and wake you up, like somebody calling from Europe, when they're going to award the Nobel Prize to somebody. And then I thought, well, I don't really want to get up at 3 a.m. So maybe I'm going to avoid that. But, it's really an honor for us to have you as our first recipient. And, I think what we're hoping that people will see is that, instead of like giving our recipients a plaque, on our website, the Texas Water Journal's website, we're going to have a page devoted to you and your career. And this podcast will be linked to it if the rest of the podcast turns out well. If not, well, won't be, but but it's going to feature all the things that you've done, and so we appreciate you, and thank you, and congratulations.
Well, thank you very much. That sounds fantastic. I'm very honored and appreciate very much that you and the board have thought about me this way.
Well, you earned it for sure. So one of the things that we cited in naming you the recipient for this award is your work on the RAP. And so, kind of going back over that again for those of you who are not familiar with that acronym. And, I have a rule on this podcast, if anybody uses an acronym, they got to say what it means. The Water Rights Analysis Package. And so tell us about the RAP, how it's used, and how you led the development of the RAP.
Well, we're really talking about two acronyms here. The Water Rights Analysis Package, RAP, is a generalized modeling system that simulates water management that can be applied any place on the planet. Water availability models, WAMs,
Yep,
are input data sets for the RAP simulation model. And this is how it's organized. There's a Texas A&M University RAP website that has the generalized modeling software, Texas Water Resources Institute technical reports that serve as manuals for the generalized modeling system, TCEQ sponsored online training courses, other publications, and so forth. And then there's a TCEQ, Texas Commission on Environmental Quality, WAM, Water Availability Modeling website that has the RAP input data sets that cover the entire state of Texas. The river basins are divided in 15 major and 8 coastal basins. That's 23 total, but they're combined in such a way that there are 20 WAMs, input data sets for RAP. The two websites that I just mentioned are interlinked. So if you're on one website, if you're on the TCEQ website, you can click a link that takes you to the RAP website. If you're on the RAP website, you click and it takes you to the WAM website. They both have an array of information that can be used in combination. The RAP modeling system actually dates back a long further than I like to remember to early work, federal state partnership efforts administered through the Texas Water Resources Institute. And then in 1997, Senate Bill 1 was enacted by the legislature in 1997. That's a major comprehensive water bill, and it has multiple components, but two components are very pertinent to our discussion today. And one is it basically said that the state of Texas has spent a lot of time implementing a water allocation, water rights system. But to really manage it well, we need to know how much water we're managing on a reliability risk, probabilistic basis. So we need a modeling system.
Gotcha.
And then Senate Bill 1 also said that Texas has a long history of state water planning. A lot of us know about the 1968 water plan, but right. A lot of this was statewide planning. And water management also occurs at the local level. So Senate Bill 1 said we need to divide the state into 16 regions and put into place a process, 5-year planning cycle, 20. So our 16 regional reports, our statewide reports, Water for Texas 2002, Water for Texas 2007, Water for Texas 2012, 2017, 2022, and I think you get the drift of what everyone's working on now, Water for Texas 2027.
Right.
And so the TCEQ is in charge of the water availability modeling because it's really motivated by the water rights system. As a matter of fact, the water rights analysis system is called just a water rights program. And then the Water Development Board is in charge of the regional statewide planning, but the two agencies work in collaboration and partnership to have a water right permit approved or an amendment to an existing permit approved. An applicant has to meet various criteria, which includes running the modeling system and showing that the reliabilities, both for what's being proposed and the impacts on other water users, are acceptable, and also that the whatever is being proposed is addressed in the state and regional water plans. And so in my mind, it's a major step forward where the state of Texas is, in my mind, a model for the rest of the U.S., in which we're in a very comprehensive way of putting together a lot of different aspects of water management. And of course, my involvement has been more on the computer modeling part of that. But of course, the water allocation aspects, the regional statewide planning aspects is really what the water modeling, simulation, and reliability analysis and so forth is supporting. And so then in addition to this, the TCEQ requires applicants to use the modeling system. The TCEQ staff uses the modeling system to review permit applications. The Water Development Board and the 16 regional water groups they work with use the modeling system. So just naturally, the river authorities and water management entities are using the modeling system for their purposes, operational planning, feasibility planning. And then there's been a number of different research endeavors, both in the agencies and at Texas A&M University. One example that's going on now, the Bureau of Economic Geology at the University of Texas, under sponsorship of TCEQ, is looking at aquifer recharge, and they're using the RAP-WAM modeling system to evaluate stream flow, unappropriated stream flow that's available for different types of aquifer recharge projects. I'm putting that in the research category. And so, and I guess I would sum up RAP. This is what I think is very interesting and important about the RAP-WAM modeling system, and that's the institutional aspects of computer simulation modeling analysis. And there's two sort of what I call institutional dimensions or institutional aspects. One is the modeling system, to be successful, required an entire water management community to be involved in the modeling system. The agencies working in collaboration, the consulting firms working for the agency, and even the universities help out a little. So it's sort of an institutional framework of a community working together to make beneficial use of computer modeling. And then secondly, the water allocation system, water rights and contracts between federal reservoir operators and non-federal water suppliers. There's a lot of institutional aspects of water management that's included in the simulation model, as well as the river system hydrology and the constructed infrastructure that's operated in the modeling system. And so that's basically wrapping and whamming, the RAP and WHAM system.
Well, so just wanted to mention here, you mentioned the Bureau of Economic Geology at the University of Texas. They're one of the partners now that publish the Texas Water Journal. Okay. And so wanted to make sure I mentioned that. And just kind of to recap a little bit, the RAP and the WHAM, they're used not only for planning, which they're a key element of that, but they're also used to do an analysis of how changes to individual surface water right permits might affect other permits. And so, they've got a whole range of functions that they fulfill, and they're used by, as you mentioned, the TCEQ and the Texas Water Development Board and the regional water planning groups that are managed by the board, and consultants and river authorities and researchers and the public. I mean, anybody can use this model. Isn't that accurate?
It's in the public domain. It's not necessarily trivial. There needs to be a level of experience and expertise, but the actual software, I think the 6 manuals are maybe 1,500 pages long, and there are training courses. I think 30, 40 hours of training courses, but everything's in the public domain on both sides. One side being the water rights analysis package, the RAP and generalized modeling system. The other side being the TCEQ website with the input data sets. The input data sets are not only in the public domain, but the reason, or one of the motivations for the TCEQ, is they require the modeling to support their administration of the water right permit application system. Many of the river authorities have the in-house capability to do all the modeling they need to do.
Right.
Many water right managers need to hire consulting engineering firms to support their permit applications and the modeling that supports those. Of course, TCEQ has its own staff to do the modeling. And so there is, as we've talked about, a community here that makes it all work.
Right. One of the things that I think is tells you the most about the RAP and the WAM is that it's so ubiquitous in terms of its use in water management in Texas. And I've been involved with a lot of water projects, and it's rare to hear people say, "Oh, well, I don't believe what the WAM says," or WAM's projecting. I mean, the confidence in it is really pretty remarkable when you look at other types of models. I'm familiar with a bunch of different types, particularly on the groundwater side too, but other surface water models that have come and gone, or maybe still out there along the way. I just I never really hear when it comes to the RAP and the WAM, people saying, well, I just don't really buy what it's saying. I mean, that's not how people talk about the results of that. I mean, just really kind of marrow deep kind of confidence in it. And so that's a testament to the work that went into it. As you said, a lot of people had an opportunity to participate in the development over the years.
Well, that's encouraging to hear. And there has been a tremendous amount of effort by a lot of people in it. And I think maybe another aspect of the credibility is under TCEQ leadership in collaboration with its partner agencies, there's been a lot of communication. I'm going to give you a couple of examples. The RAP user group conferences. Mm-hmm. I guess the last RAP user group conference was, they're always hosted in coordination with Kathy Alexander and her group at the TCEQ, but everyone's involved.
Right.
I think the last one was hosted by the Lower Colorado River Authority at their Rosebud Conference Center in Austin.
Yep.
The Brazos River Authority has agreed to do the next one, and coming up soon. Some of the consulting firms have hosted some of them. And I think if we all come together and we have the regulatory agency, the planning agency folks, the consultants, the water utilities, if we all sort of talk together, it builds a sense of credibility.
Right.
And also, if something's wrong, those people are going to tell the TCEQ, and they're going to get with me, and we're going to try to make it work correctly. And I said two examples. Another example, the Texas Water Conservation Association has a RAP subcommittee of the Surface Water Committee of the Texas Water Conservation Association. The last time, again, Kathy Alexander and her colleagues and group at TCEQ brought us together was just a couple of months ago. I think there were probably about 35 of us. But again, they review what TCEQ and its partners are doing. They provide input that helps develop the modeling system, and perhaps it helps build a sense of credibility that we're all part of this, and so we all want it to work right.
Right. Well, using the RAP, does definitely give people confidence in, what's going to happen or what's not going to happen with the project they're looking at or changes to permits. And so that's a really key element of it. And, but you've done other things besides the RAP. I don't want people to think that that's the only thing that you've worked on. You've done a lot more. And so why don't you tell us about some of the other projects that you've been part of over your career that you found the most interesting?
Well, as I mentioned before, I began in the Water Resources Development Program of the U.S. Army Corps of Engineers as a regular Corps employee in Fort Worth District. But after I came to the faculty of the Texas A&M University, I stayed in contact with the Corps and did quite a bit of work with Fort Worth District, but also with the Engineering Research and Development Center of the Corps in Vicksburg, Mississippi, the Institute for Water Resources in Alexandria, Virginia, the Hydrologic Engineering Center in Davis, California, the Waterways Experiment Station Engineering Research and Development Center in Vicksburg. I worked in the military hydrology program. And one of my recollections there, I've only had one graduate student that I've worked with that's had his work classified by the military, which delayed his graduation with his MS degree because the university requires that a thesis be published in the university library.
Okay.
And we were working in the military hydrology program doing dam breach analysis. Dam breach analysis actually has a military significance. Our case study was Korea. And the concept was that if there's hostilities between the North and the South, there could be breaching of dams.
Right.
And so I had two Master of Science or Master degree advisees. Both were captains in the military. And one he's now retired as a colonel in the military. But basically what happened, he developed a modeling plan for responding to what if the North invades and we're afraid that the dams are going to be breached. Let's draw them down. But then what happened to him, this was unanticipated. It had a good side, but it had a little bit of a drawback. The good side was the military got very interested. It became politically as well as technically interesting. And so his next assignment was to spend several years continuing with his master's work at the Waterways Experiment Station Engineering Research Development Center and in Korea. The downside was he was not allowed to publish his thesis.
Oh, God.
So it took a little negotiations, and finally the military allowed him to I think the word's redact, where you
I was going to say, it was you go to the library and you open up his thesis and it's like, oh, funny, gosh.
And so, yes, he was able to publish his thesis in the library. And so he did complete his graduate degree. But as it turned out, the project had some significance, some political significance because of some things that happened in Korea during that era.
Right.
And then the Institute for Water Resources, I worked in the National Study of Water Management during drought. And that provided an opportunity to look at some drought management activities that the Corps was in some way involved with in collaboration with non-federal entities in different parts of the country. And then I've always, one of my favorite places professionally is the Hydrologic Engineering Center of the Corps. They produce so much software that's made such an impact, particularly in flooding, regulating floodplains for the National Flood Insurance Program throughout the nation, and so forth. And there, my focus was more on storage reallocations between flood control, conservation, hydropower. And also we did quite a bit of work on flood risk and reliability analysis, and the term uncertainty analysis became very popular. And I think the HEC sort of led some efforts on, the concept is we run a computer model and we get deterministic numbers and those are the answers. But in actuality, there's a large degree of uncertainty that you want to quantify. And so I did some work with them, and there's been some graduate students that have been involved in different aspects of that. And I've sort of transitioned more from flood control, flood mitigation toward water allocation, water management as the years have progressed. I'm very focused on the TCEQ RAP-WAM modeling at present.
Right. Well, kind of going back to what you were saying earlier, I came this close to getting a trip to Vicksburg and getting a tour of the Waterworks Experiment Station. And I can't remember exactly what happened. I think, I was going with the general manager of the River Authority, and at the last minute, they I don't know, I got bumped or somebody got my spot. I didn't get to see it, but it was, I came close. But I was just thinking about, the what you were saying about the research on breaching dams. I mean, most people are probably familiar with the story of the RAF bombing the German dams during the Second World War. And of course, much more recently than that, the Russians destroyed a dam that flooded parts of Ukraine. And so, that's a real issue in terms of the kinds of things that can happen.
I did receive I actually mentioned a couple of former graduate students in the military, and I did recently, some time ago, receive an email that was showing some aerial photos of the, at this moment it slips my mind, the dam that's in Ukraine. And I haven't followed this, but apparently there has been some flooding in Ukraine that, let's say, I think it's at least as strongly suspected may have been done purposely.
Right.
And so the whole concept of trafficability, using hydraulic warfare to keep troops from being able to move, that's part of the military. That's my very distant past, though. But also on the civilian side, dam safety. The TCEQ has a non-federal dam safety program. The Corps has its dam safety program. Rehabilitation of an aging infrastructure of dams that have been built a long time ago. Some experiences on the Guadalupe River with spillways coming loose.
Right.
Just the whole concept of dam safety, dam breach analysis has a very civilian, non-military aspect to it as well.
Yeah, by the way, we do have a submission on that the Water Journal is reviewing right now about that whole issue on the Guadalupe.
Oh, okay.
Yeah. Mm-hmm. You mentioned you looked at reallocation and reservoirs. And so, I was interested in that just because, that was an issue that came up for Canyon Reservoir when I worked for the Guadalupe Blanco River Authority. Was there a way to get the Corps to not evacuate kind of that final foot of flood storage, so that, or to, evacuate it slower or something like that, so that maybe that additional increment of water could be applied to water supply, for example. And I know that that's an idea that's cropping up more and more, but it's not something that's easy to change in terms of the management of those reservoirs, and whether ever becomes a a real option to get some additional storage without having to build a new reservoir project. We'll see, but you do hear people talking about that more and more. What are your thoughts on that?
Well, it's probably worth mentioning just for background, as you and I both understand, the flood control storage in the 30 Corps reservoirs are totally controlled by the Corps of Engineers.
Right.
That storage the Corps projects were built with federal funds by the Corps of Engineers, pursuant 1936 Flood Control Act. And then the 1958 Water Supply Act said that the Corps should encourage non-federal water supply sponsors to include water supply, subject to all costs allocated to water supply being reimbursed by the non-federal sponsors. So there's more multiple purpose reservoirs with large flood control storage plus non-federal or federal storage that's being all cost reimbursed by non-federal sponsors for water supply than any other state by far. The second would be Oklahoma. And so what's happening now? Well, I guess International Boundary Commission, same thing. They operate their own flood control and water supply, but we have a large volume of flood control storage sitting there. And I mean, flooding is important.
Right.
It's needed for flood control.
Right.
But in the same reservoir, we have volumes of conservation water supply storage. And one common type of reallocation is just simply raise the top of conservation water supply pool. For example, Lake Waco at the city of Waco, about 1985, the top of conservation pool was raised 7 feet. And that reallocated about 15% of the flood control storage to water supply. And there have been actual reallocations, and there's been more studies, feasibility studies, proposals that have not actually happened. But as we have greater demands on our water supply storage, one logical thing is just to convert flood control storage to water supply. And I'm talking, or have been, about permanent reallocations.
Right.
There's also possibilities for temporary or seasonal reallocations, which are common in some other states that have very distinct flood seasons.
Right.
Texas, we can have floods any time of the year, though it may be more likely in some time. So we haven't done seasonal rule curve reallocation. And then within the conservation pool, there can be reallocations between hydropower and water supply. For example, the largest reservoir in Texas, if you include both flood control and water supply, is Texoma. And the natural salt pollution problem has constrained its water supply use. Right. So it's been used mainly for hydropower. But as our demands for water supply increase, there can be reallocations of hydropower to a greater use of water supply in spite of the salinity problem.
Yep.
The same thing can be said about Lake Whitney on the Brazos. Salinity upstream has made some constraints that encourages hydropower. Yep. But there can be some reallocations from hydropower to water supply too.
Yeah, so I've spent decades duck hunting on Lake Texoma. And I duck hunted on the west end, which was the shallow end. Of course, that's where the Red River was coming into the reservoir. And I've learned after a few years that, the key element there, one of the key elements was how much was being released from Texoma to generate hydropower. Because, when they were really releasing water in the shallow end to the west, that would make a huge difference in terms of whether you could get a boat back there, or whether, the habitat was high and dry. And so I started calling up the Corps' office and asking them, this is in the 80s and 90s, nothing on the internet, because there was really no public internet or anything at that time. And I think they got kind of tired of hearing from me, pleading not to generate some hydropower until Monday because I was going to be out there or something. But I think, you're absolutely right. That's something that is going to get a lot more attention in the future. I, wasn't familiar with what Waco had done, but it's interesting to me. I just want a follow-up question on that one. So when they reallocated the flood storage to water supply, did they have to make any physical changes to the dam, or was the dam rated to handle that increased volume over a long period of time and without any, changes to the structure required?
Well, the changes were minimal compared to constructing a new project, because when the pool raised, it covered up boat ramps and picnic areas and park roads. And so there had to be some reallocations of certain facilities, but basically the basic dam outlet structures stay in place. And so, and there are some rules, going back to institutional considerations. If the reallocation involves too large of a storage capacity, my understanding is the Corps has to go back to the U.S. Congress for authorization. But if it can be relatively small reallocations within the Corps without going back to the U.S. Congress for authorization, there's some flexibility for doing reallocations that don't involve high levels of storage capacity being changed.
This is a whole podcast episode, this topic. We might have to come back and talk about this again sometime. But
on Texoma and your interest in fishing and hunting and so forth, and this illustrates how multiple dimensions fit together. We were talking about reallocation, flood control, hydropower, and water supply. Water supply is driven a lot by the salinity in the Permian Basin, natural salt pollution from the Permian Basin geologic area, which also affects the Pecos and the Colorado and the Brazos, as well as the Red. But one of the things, just your comment about hunting but fishing, is that the water supply people would like to have a greater water supply use, so they would like to do salt control dams upstream of Texoma.
Yeah.
But the fishermen, fisherwomen, like to catch the striped bass, which can only survive in a certain level of salinity, and there's some other ecosystems that could be affected if you reduce the salinity.
Right.
And so all of this, there are different views, different beneficiaries, different stakeholders that may look at things differently, whether it's flooding, water supply, hydropower, fishing, hunting, ecosystems, and it makes water management interesting.
Oh, it sure does. I've been striper fishing on Texoma, and just kind of thinking a little bit closer to home here about trout being released into the Guadalupe River and how that has influenced decisions on the management of releases from Canyon Dam. Falls right in the same category. And that's what makes water resources management so fun, right?
That's right.
Well, so tell me about your teaching at A&M. What you've done that for a number of decades now, and you're still teaching. What have you enjoyed most about teaching over your career?
Well, I do enjoy teaching. I've taught a large number of different courses, and I've always enjoyed teaching. I also enjoy the diversity of interactions between working, sort of combining research development, consulting, and teaching. And the two blend together. The academic community, the professional community, and I've been around so long that now the professional community has a lot of my former students. And I think the students like an interaction between the academic community and professional community. So I do enjoy that, sort of the diversity of different aspects of of my job. And of course, teaching I enjoy, but sort of doing a bit of research and development and consulting and so forth along with that.
Do you still hear from some of the students you taught in the early years of your teaching career?
Yes, in different ways. I'll mention at least a couple. We talked about the RAP users group conferences and the Texas Water Conservation Association's RAP subcommittee. Now, there's a lot of professionals involved in these endeavors, and many are not my former students. But again, a lot of them are my former students. So I see them through the RAP activities. And also, I've worked for many of them as a consultant. They'll hire me in their firm to work as a consultant. And then this past week, totally unexpected. This is a complete surprise. Totally unexpected. It turns out that a group of former students have gathered together and endowed a water resources graduate fellowship. It's an endowed fellowship in water resources, and they're calling it the Ralph A. Wurbs Endowed Fellowship in Water Resources, which I'm very honored that they would consider naming their fellowship, which a significantly large group is endowed with my name.
So that is fantastic.
Very, very pleasant surprise last week to learn about that.
Well, congratulations on that as well. I bet that, what an honor. And, thinking about, the, Texas Water Journal Lifetime Achievement Award, but not only that, what you just told us and was looking at, your bio, you're an honorary diplomat for the Water Resources Engineer, or Water Resources Engineer by the American Academy of Water Resources Engineers. That's a rare honor. But you're also selected as the inaugural American Academy of Water Resources Engineers Outstanding Research and Innovation Award recipient. What is it like? Because I don't know. What is it like to be recognized by your peers for all these extraordinary accomplishments over your career?
Well, as we've talked about in this podcast, I've been very fortunate, I feel, to be involved in endeavors that have involved impactful collaboration between a lot of different people in different communities, multiple disciplinary communities, civil engineering, academic, professional, and this has been enjoyable. And some of these recognitions are just pleasant reminders that I've been fortunate to participate in some of these endeavors that have involved my professional colleagues and stakeholders and former students and current students. So I feel very, very fortunate. And these are nice reminders of how fortunate I've been in that regard.
That's great. That's great. Well, Ralph, we're going to kind of start to wrap up here. And so I want to ask you this final question. How can our listeners learn more about, the things that you're working on right now?
Well, we've talked about in the podcast the RAP-WAM modeling system, and I've already said that there are two websites: a RAP website at Texas A&M, a WAM website at TCEQ. TCEQ does a great job of keeping their stakeholders informed of what's happening, and those websites have publications, even training courses, so forth. And we've also mentioned that I have published several papers, 4 papers in the Texas Water Journal. The Texas Water Journal is conveniently accessible. It's actually free of charge, and the Texas Water Journal is a wonderful source of information about a broad range of issues and endeavors in the state of Texas to manage water, and that includes some of the things I'm involved in too. And then finally, my new book. I'm going to tell you the title again. and it's coming out in the next few weeks, and it may be of interest to some people.
Sure.
The title and subtitle. The title is Managing Water in Rivers and Reservoirs, and the subtitle is Water Resources, Institutional Processes, and Constructed Infrastructure in Texas. So some of the things we've talked about today, you can read about in greater detail in that particular book.
Great. Well, let me just say thank you for the shout out for Texas Water Journal. That check's in the mail for that.
Okay.
We're going to be having, I think, Kathy Alexander. I know she is because she told me she was. She's going to do a review of your new book.
Oh, I appreciate her doing that.
And we'll publish that in the journal. And the other way that our listeners can find out more about your career is that in the not too distant future, we're going to have the dedicated webpage as part of your receiving the Lifetime Achievement Award on the Texas Water Journal website. And we'll have links to your articles, at least the Texas Water Journal articles, and your bio and your photo and a link to this podcast. So,
that's wonderful.
So that's another place that they can go.
Okay.
Yeah. Well, Ralph, it's been great talking with you. I really have enjoyed this.
I've enjoyed the visit too, Todd. I always enjoy visiting with you, and the podcast has been a fun thing to do.
Oh, great! I'm glad you did a great job. By the way, you did a better job than I did. So, hey, and I've done 73. This is the 73rd. So, congratulations on that.
Thank you.
This has been Talkless Water. My guest today was Dr. Ralph Wurbs, a professor in the Department of Civil Engineering at Texas A&M University and the inaugural recipient of the Texas Water Journal's Texas Water Lifetime Achievement Award. I want to thank you, the listener, for spending your valuable time listening to Talkless Water, and I want to thank Anna Huff at the Meadows Center for Water and the Environment at Texas State University for getting every episode of Talkless Water ready to go. My name is Todd Bottler, and this has been Talkless Water. Let's talk water again soon.